power is still 8, an even power. All right. Same idea here. Now this time I wouldn't need absolute values either way because it says already assume variables represent non-negative values. So even if I was evenly rooting an even number which resulted in an odd power, I wouldn't need absolute values anymore, but that actually becomes an even power anyways. And well, maybe before we move on, let's just explain what's happening here with this example also. So why is that x to the sixths? Maybe we blew past that a little bit. That ends up being x to the sixth because, because if you're square rooting x to the sixth, all right, just like this idea right here, the answer is 3 because I found that 3 cubed can be 27, and a cube root and something cubed will just cancel. The idea is if I have x to the 12th, I'm asking myself what thing multiplied to itself will give me x to the 12th. Or in other words, how can I write something squared which is x to the 12th? And if we think back to our exponent rules, x to the 6th squared is x to the 12th, because if I have an exponent raised to an additional exponent, they'll multiply. So the reason that this just becomes x to the 6th is because since I can write the square root of something squared, well then the square root and the squared will cancel and I'm simply left with what's on the inside. So that's the idea going on there in those types of questions when the power is greater than 2. All right, so following up that idea, also we have non-negative numbers, so now that absolute value rule does not apply. So maybe I'll put this extra note here. If x can represent only non-negative values, aka if x can be any real number. So that's what that rule is fully. It needs, that rule only matters if x can be any real number, or in other words, if it doesn't only represent non-negative values. So this says it does represent non-negative values, so I don't need to worry about that absolute value rule. I can simply square root like normal. So 36 roots to 6th. X to the 4th squared is x to the 8th, so since x to the 4th is being squared, I'm just left with that. And same thing, I would have y to the 9th, since y to the 9th squared is what gives me 18. All right. Well, this is simply going to be x because a 9th root to the 9th power. Again, the idea is I was able to write the nth root of something to the nth power, and those will just cancel themselves out perfectly. All right. Now I have an 18th power to the 6th. So the question is, again, how can I, in this case, not square root, I do need that nth root. All right, again, the question here is how can I write 18 as something to the 6th power? So let me copy that. Well, let's see here. How can I write that as something to the 6th power? Well, I could write that as x cubed to the 6th power, because then the 3 and the 6 would multiply because that's the power to power rule. And now that 6th root and the 6th power will cancel, so the answer is simply x cubed. All right, almost done with 8.1. So now we have some function evaluating. So f of 5 simply means take f of x and replace x with 5. Well, if I replace that x with 5, grab some of that. If I replace that x with 5, just a second here, okay, then I'm going to have 7 times 5 plus 29. Well, that's 35 plus 29, and that's 64, which is just 8. All right, do the same thing, so I'll skip over that. Actually, that one looks like the radical might not fully go away. Yeah, that actually, if you plug 2 in, you'll get just square root 7, so that would be your answer there. Up next, explain how to determine the domain of the radical function. I'm going to skip over that and just kind of dive right into write down what this is. Well, so what we've said before is we've said that the what's inside of an even root must be positive. So the domain refers to essentially what are you allowed to plug in. So, well, what's inside of that root is 4x minus 5. And so, again, to be able to evenly root something, we're saying what is inside of that root, aka that whole algebraic expression, must be greater than or equal to 0. All right, we can't square root a negative, so what's inside of my algebra cannot be negative, aka it must be either greater than 0 or equal to 0, but it definitely cannot be less than 0. So this expression represents the domain of that function. Well, we need to algebraically simplify that, and we can do that by adding 5 and then dividing 4, and if you do that, you're going to end up saying that x is greater than or equal to, well, 5 over 4. Oops. And that would be your domain of your function. So which answer choice looks like that? Well, A looks like that. And I believe 28 will work in a similar fashion. Yep. So that gets us through 8.1.